Hello. Thanks
Hi.
so much. Hello, everyone. I'm Heloisa. I'm a software engineering at Nubank, and today I brought a very different topic for this environment. Let's say like this, which are the advantages of functional programming with Clojure. And this is not going to be like a very technical talk. I want to approach this in a more business way. So how you would choose like a programming language for the company, why you'd choose like a functional programming language for a company. And I want to focus in Clojure, which is the language that I have been in touch for the past 3 years, and it's a language that I think nowadays it's probably my favorite one. And I think it's something that the environment of IT should take a look more close, because it's something that has been like helping a lot. And to understand those advantages, there are a few things that we need to know about functional programming, because as you might know, there are a few different languages nowadays. Actually, there are a lot of them, but most part of them follow different protocols, let's say like this. But they follow different paradigms, which are different ways to solve problems. So they have like different approaches, and normally we choose programming language to try to solve something that language might be better. So when we are talking about functional programming, we also have a few guidelines and concepts of implementation that those languages that follow this protocol have some like benefits, and try to use it to have like a better approach in solving like testing and debugging. And they are like what we seek with functional programming. So the first thing is that we seek services that are going to be totally mutable. So we won't have like variables changing over time, because in that way we are totally able to have control over the code. Because, for example, nowadays one of the most used programming language at the market is Java, which is oriented objected programming language, and it doesn't follow the immutability protocol. So sometimes it's really hard for you to debug problems when you're having them, because you don't have like control of what's happening in the whole process of the service. And with functional programming, we do try to have it like the best that we can. And also, as the name already says, functional programming, the idea is to try to split our problems in function situations. So in what way I can split my problems here to try to put them in small functions that are going to be totally testable, because in that way we're going to have like a high coverage to the scenarios that our service is going like to apply. And also we try to have pure functions. We might understand pure functions as mathematical functions. So if you have like an x that is something, the result is always going to be the exactly y that you have. So you're totally able to predict what this function is doing and the return that is going to give you based in the inputs that you have. So those concepts really help us to have like a high, concise idea in the programming language. And also we seek functions composition. So we normally think about the problems as a composition of functions that we might apply to this problem. And what is different from other paradigms as well is that normally in functional programming, we seek recursions over loops when we need to iterate over a collection. So we don't have like for each situations. We always use like recursion over the collection. And also we prefer expressions over statements. Expressions we might understand as the example of the mathematical function, in which you always have like a result for the inputs that you gave. And the statements, which are the things that we try to avoid, are functions that don't have a result. So for example, if you have like a function that do like many calls to like a step-by-step thing, and you don't have like anything being returned, just a void, this function is a statement. So in functional programming, we try to have only expressions in our way of doing things, because in that way, it's easier for us to know exactly what's happening during the whole programming situation, execution time. And there are a few things as well that we try to avoid, and they are totally related with the things that I mentioned. So we avoid as much as we can the shared states. So we don't want to have like variables being mutated over time, change it, and being used like without control. So this is something that we truly try to not use. If there is like a scenario in which you need, maybe you are totally able to do it, but it's not really recommended. And also, we try to avoid side effects. For those that don't know exactly what are side effects are everything that goes outside of a service. So, for example, an error being thrown, a print to the screen, a connection to a database, an HTTP call to other service, and so on. All those things are side effects. Of course, our services will need to have side effects, but with functional programming, we at least try to separate it in the best way that we can, because in that way we will have like this more accurate service being created. So after telling you all those concepts that we try to have with functional programming, just to clarify a bit the idea, I want to deep dive more in Clojure and what it is the difference of Clojure to the other language, and why it would be nice to implement it and how to implement it in a company. But to start, I think it's nice just to know a little bit about the history, because this is something that is normally really common for you to know the history of the language. But in this case, I think it's really important, because it makes like the foundation of what Clojure it is. So it is a really young programming language. So it was released in 2007 by Rich Hickey, and this functional programming was created to be designed to be a general purpose practical functional programming language, which would be suitable for any professional in which the host language was Java. And how we would do this, right? So Clojure is built in the top of the JVM, which is the Java virtual machine. So the environment that runs Java, for example. So to have a functional programming language running in this environment is something that allows not only someone that wants to learn this language to use it, but anyone that has this JVM already configured and had an infrastructure created, so it's really easy for you to start using. So this idea of having it is to bring functional programming language more close to the market, because nowadays this has been changing in the past few years, but it's still like a few number of companies that use functional programming language, mostly because in the past functional programming was only an academic idea. So normally we just like used functional programming language at college, at courses when we wanted to do so. It wasn't even in the syllables of the graduation, for example. So with this idea of having Clojure closer to a Java environment, this brought a more easily way for people to try to use it without having to do it by themselves, because it was going to be like much easier. So this was one of the fundamentals idea for the conception of this programming language. And it also is an open source, so you're totally able to have access to the code and modify it if you want, and do collaboration to it. And it follows the Lisp dialect. The Lisp dialect is the grammar of the functional programming language, and Lisp was the first functional programming language created in the academic world. And it was like a programming language created to solve problems with lists. So that's why the name Lisp dialect. And it has like a really different style of grammar, because it has like many parentheses. So Clojure follows this idea. So at first sight, it's really weird to see how it is like structured, the coding part. but it's really easy for you to understand how things are done. And it's really simple as far as you have like just to understand how the things are put there. You're totally able to read it and programming, and it is really, really fast to teach others to use it. And Richie has done some modifications in this Lisp dialect just to make it more understandable with some like more additions. But in the most, it follows this dialect, which is really good because there are many other programming languages that follow as well. So now I want to get to a use case of how we would use Clojure and why a company would choose to use Clojure, right? So what are the benefits and the advantages that it would have to make it like choose to use a so different and not so usual programming language. So the first thing is that Clojure is really objective. So you don't have to have like many lines of code to have something running and doing like stuff. As Java has like a really verbose programming style, Clojure is totally different and it's much more direct to the point. So it's really fast to have things running. So this is a really good advantage of it. And the other thing that I think it's one of the most important, not only for developers, but also to the company itself and to the business level, which is that we have like an outstanding test coverage with this language. And what I want to say with that, right? So as we have those ideas implemented of so pure functions and being able to predict everything that is happening, you're totally able to have a high coverage of test unity, integration tasks, and so on in the service. And you might have like an almost full coverage in a single microservice. And in that way, you're not only guaranteeing the quality of that service, but also guaranteeing the quality assurance of that. So sometimes we saw companies having like separated teams of quality assurance to validate and see if what has been done it's okay. And when you have like a language that by itself has the principle of doing it as its like main status, this thing might change flow. For example, at Nubank, we don't have a separated team to do the quality assurance. We only have the services being tested by themselves. So the developers are able to do like the full coverage of testing much more precisely and with indirect to the point without much effort. So it's easier and very good to the company that don't have to waste money to have like more people working in different chapters. So this is something really, really nice. And other thing is that as it is built in the top of the JVM, as I mentioned, it has full interoperability with Java. So we are totally able to use all the libraries available to Java, all the things that are already done. So you have like direct interoperability. So you're totally able to just import there and use. You don't have like to do like a difficult thing. So this is quite useful as well. And also it has like a strong community, and it's very easy for you to get tutorials, understand things, and ask questions because all the community is really receptive and able to do it, to talk to you if you need. So this is quite good. And how we would use Clojure in a company, right? I think this part we can take a look not only to Clojure, but at any programming language that a company would choose. So how it would use the language itself. So the first thing I think, in my opinion, is if you want to use like a microservices architecture as it is like the most used today and that has the more reliability, the first thing is to decide the language and use a single language to most parts of your microservices. So I would say that to have like around 90% of microservices using the same language, so in my case Clojure, would be like the best scenario, because in that way you're totally able to have like a single infrastructure being created and evolved over time. So you don't have like to decide, oh, now I'm going to use Java, now I'm going to use Python, now I'm going to use other functional programming language. And when you have like many different languages, it's really hard for you to have control over the infrastructure, so you're not able to automate many things. So when you have like a single programming language, this is much more easier, and you might evolve the whole scenario as a single thing. So this is something really good to do, so to choose a language and follow it for the whole idea, only when it's extremely necessary to use a different one. And other thing is to have a predefined architecture for the microservices that you're going to build. So imagine a scenario in which the company has scaled so much that you have like more than 100 microservices being created. And if you don't have like a defined architecture, it's really hard for you to be able to do maintenance, to change people when you need, and do those things. So, for example, with Clojure, the diplomat architecture is an architecture that is really nice to use. I will talk more about it like in a single moment, but this is something that I think it's really useful for all the developers to be able to act, to work in a more precisely way and in a more faster way as well, because you don't need to take time understanding what's happening, as all the microservices follow the same structure. And also, when you have this whole infrastructure created through a single programming language, we might be able to include continuous delivery, which is the idea of coding, testing, and doing the validations and put it direct to production. So this I will talk more as well, but all those things are things that you might do to have it running at the company. And when I talk about the diplomat architecture, this is a known architecture. So hexagonal architecture is a very well-known architecture for microservice, which follows this idea of ports and adapters. So it has like the idea of having an anti-corruption layer scenario to avoid breaking chains in services. But the diplomat architecture is pretty much the hexagonal architecture with two levels of business logic in the part of the context. So what I want to say is that it has like one more step inside this idea of hexagonal architecture. So how I would do it in Clojure, I would have like this structure of a project in which I would have this diplomat, which was going to be the authorization part to negotiate on behalf of the service. So everything that needs to be negotiated, so things that are arriving to the service, HTTP calls that are arriving, HTTP calls that I'm sending to other service, events and the message part if you use it. So all those things would be handled by this diplomat part, and we would have like input and output to those ports. So the ideas of ports are all those connections that the microservice would have to the outside world with other microservices or other infrastructures. And we also would have a predefined external schema. So we would have like a contract, a defined contract to those ports. And we would also have another internal schema, which would be our internal model, which is like the model that the context knows. So they are different because we need to have this part of anti-corruption layer, which are the adapters, to change from the external schemas to the internal schemas to guarantee that these scenarios wouldn't like break if something changes inside of our context of the service. And also we would have this more internal part that is inside of the internal model, which is the controllers. And this is like the first level of business logic, and would not only have this adaptations being performed there, but also would have all the interactions with other other things. So if I need to have like a connection to a database or to ask things, this is where I would do this interaction. So here the side effects would be all concise implemented, because as I mentioned in the beginning of the presentation about the ideas of not trying to avoid the side effects, so here would be the place in where we would put all the side effects to be able to handle them in an integration test way. And to finalize, I would have the pure logics, which would be the exactly idea of having a function being created extremely pure. So with an X that I gave, I would have the exactly Y that I was expecting. So the idea of pure mathematical functions. And the continuous delivery would be done for with the coding of the programming language, the microservice. Then I would do like testing, unit testing, in integration tests. The integration test, for those that don't know, I know that I talked about it, is to try to predict all the side effects that the service is generating. So as we try to avoid the side effects, we at least need to have like control over them. So if I want this service to be connecting to the database and updating a table, I want to be able to check that this was done precisely well. And also, if I'm sending an event to other microservices, I want to be able to guarantee that this message has been created and sent. So the integration test is a test done to validate those side effects. And the unit testing is a more Unitarian style in which you're able to test function by function. So when you have like everything done, you're able to put it like in a repository, for example, GitHub, in which would have like a CI running. So it would run all the tests that this microservice has, would like validate contracts, would have the whole infrastructure already configured there. And in that way, we would be able to have someone outside of yourself, like another coworker, that would validate and see if things are okay and in the code conventions that you follow. And after approving, we would build the microservice thing, and we would deploy it. And after that, it would be already delivered and available to everyone to use. So this is the idea of continuous delivery, that it's quite useful to be done. And with Clojure, it's really easy as well. And with any with any programming language, it's easy. And it's something that if you follow that idea of having your infrastructure with a single programming language, it's something that it's like helps a lot to everyone, to the company and to the developers. And as I'm talking about a very different programming language, when you decide to use like something like that in a company, how you onboard people, right? Because it's difficult to hire people that know it, right? But as Clojure is a very simple language, it's easy to onboard engineers. But there are a few things that I think might be used to any programming language as well that help to do it. So the first thing is self-service online course, as nowadays it's really useful for anyone that wants to learn. It's something to start. It's a good thing, but I would say that the most important thing when you want to have like onboarded engineers truly doing hands-on activities, I think mob programming is the best thing that a company could do to teach engineers in anything that they need. And how does it work, right? So it's similar to a pair programming. I'm not sure if you have heard about the more programming, but it's very similar to a pair programming, in which you have like a group of engineers doing a task, a single task together, and they normally switch places. So after 5 to 10 minutes, they go switching places of who is coding, and they all of them give ideas of how to solve the problem, how to do it. And when you have like a new programming language to teach, this is like a very good idea, because you might have like someone from the company that already know how to do it. So I already know Clojure very well. So there is like a single person that knows Clojure but all the others are able to solve problems, right? So they give the ideas of the problem, of how they want to solve the problem, and this person that knows the language teach them how to do it in Clojure, and they program it by themselves. So they do hands-on activities, and this is something that allows people to truly understand what's happening, and it's really useful. And I think this is even very nice to do it at the teams itself, because it like shares the knowledge and increases the process of learning much more than like a single self-service online course. And other thing that I think it's really useful is to have a buddy, because sometimes when the person is new to the company, it's really hard to do questions to others. So when you have like a predefined person from who you might be able to do the questions, it's more like smoothie to do these questions, because it's easier for you. You're not like, even if it is like a simple question, you're not going to be so ashamed of asking. So this is something I think really useful to do as well. And also to have this person integrated to the team from the very beginning, because then it's going like to do pairings with the others, do more programmings with them, and in this way, with like tasks and hands-on activity, it's going to be like much faster. And just to summarize a few ideas about the Clojure and why I would choose Clojure to be used like in a company, the first thing is that it has an accelerated learning curve. So it's a really easy programming language because it has like a simple grammar, and it's really fast for you to learn how to do it and start like developing a service by yourself. I might say for experience that, for example, when I did an exercise to enter the company that I'm today, I had like 2 weeks to choose a functional programming language at that point, and make like a program. And I chose Clojure because I didn't know like any functional programming language at that time, and I decided to do it, and I was able to do it like in a week. So with like a restless API and so on. So it's really fast, even if you're like by yourself. So this allows us to learn a lot in Clojure and evolve with time. And this is something really, really good. And also it has like an amazing community and documentation. So you're totally able to find many examples over the internet and ask questions if you need. And the tutorials are quite good. So different from other languages, I think Clojure has like an extremely well done documentation, because you don't have like many descriptions. You have the descriptions, but they are direct to the point, and also you have like so many examples that it's much more easily for you to take a look and see, oh, it's exactly this that I need, not only by the idea being right. So this is quite good. And if I have to recommend something, I would say to start with this magnificent book, which is The Clojure for the Brave and True, that has a really simple didactic with a very smooth of thought. So it's quite nice and a good point of start. And make Clojure be ever in your favor and functional programming in your life. Thank you so much for watching this presentation. Now I'm open to questions if you have as well. Thank you.
Excellent. Thank you very much. I really enjoyed it. I had a question, but you were answering it about particularly around the side effects, because that's my biggest problem with functional programming. It's perfect in theory, but then the real world comes and starts trying to mess with it. Um,
Yes, it's really, this is something I think that it's really hard to predict in any programming language, but with Clojure, if you use like a good architecture, it's easier for you at least to put it like in a single place and do the testing over it to make it more like precise.
and I guess I'll throw out just I have one question, and then but if anybody else does have questions, please do post them in. One of the criticisms I've heard of hexagonal architecture is it adds a lot of overhead and a lot of like, so instead of having maybe a very simple thing, now you've got files everywhere and you've got it just adds a lot of boilerplate and a lot of complexity. So what would be your kind of comeback to that?
I think it has like you had to create like many files, and sometimes like you lose control of how many things you're doing, if any, and if you are truly following the idea of the hexagonal architecture itself. But I think the good thing is that at least you have the exactly same names for the things. So, for example, if I need to change an engineering for a team to the other because they are much more needing, because that project is much more urgent than the ones that we are here, it's much easier if you follow the same architecture than if like anyone like decide what to do, you know. So even though you have like all those files being created and sometimes that they don't make like much sense, sometimes it's better to do it in that way than to have like everyone doing they want like in a simpler way, because sometimes what's simpler for you might not be simple to the other. So to have like a predefined architecture might help in a way as well, even though it has like many files being created.
Excellent. No, it's a good counter argument. Well, that brings us to the end of our time. So just want to say thank you once again. That was a really interesting chat, and I hope everybody out there enjoyed it as well.
Thank you.